Double replacement reactions are extremely common, and these are easy to recognize because they're the only ones where you're reacting two compounds together. So we have a compound here, a mixture of more than one element, and a compound here, a combination of more than one element. So that means it automatically needs to be a double replacement reaction. You'll notice that I also have included the states of the reactants here because by those states we can tell whether the reaction will proceed or not. If you have two aqueous reactants and you get a solid in the product side, that means a reaction occurred. Or if you get a gas, that means a reaction occurred. For this class, you're just responsible for knowing whether it's solid or aqueous on the product side. And we'll talk about that as we go. Okay, so the first thing to notice about a double replacement reaction is that each one combines a metal with a nonmetal. Each compound. In a double replacement reaction, you're going to switch these ones together. So the metal from the first compound will react to the nonmetal of the second compound, and the metal from the second compound will react to the nonmetal of the first compound. Now it's important that you put the nonmetals and the metals together. Otherwise, you can't make them electrically neutral. Okay, so let's try this. We have zinc over here. So we'll put zinc on the product side. Since zinc is a metal, it will need to react with the nonmetal, or the anion from this one. And then I'm going to leave some parentheses here to remind us to go back and determine what the state of this would be. And then metals are always listed first in a chemical equation. So I'll put silver next, and that will react with the chlorine here, the nonmetal over here. Now we need, because these are both ionic, we need to determine the charges. Now zinc is a transition metal, so you can't look at the periodic table and determine what the charge of zinc is. But what we can do is look over on the reactant side here and determine what the charge is here. So we know from the periodic table that chlorine has a -1 charge. Since chlorine's charge is -1 and there's two of them, the total negative charge on this compound is -2, which means the total positive charge has to be 2+, and since there's only one zinc, that means the charge on this zinc is 2+. And that charge is going to be carried over here to this zinc. So this zinc will be 2+. We know that the nitrate has a 1- charge, and since this is an ionic compound, again, we want to make sure that this balances so that it's electrically neutral. So we have zinc nitrate, like this, and then our other one is silver chloride. Silver, again, is a transition metal, so we can look back up here at the reactant side of the equation. We know nitrate has a -1 charge. There's just one. So the total negative charge in this compound is -1, so the total positive charge has to be +1 to cancel that out, which gives silver a +1 charge. Chlorine also has a 1 charge, but this is a -1 charge, and so silver chloride is just AgCl. So now that we have predicted our possible products, we're going to look at the solubility chart to see what the states of these products are. If either of those is a solid, then a reaction occurs, and we will go back and balance the equation. I know the solubility chart is hard to read, but you will have a copy of this. It's easier to read on exams, and you should have one in your notes as well. So our first compound was zinc nitrate. So we look for either zinc or nitrate. Nitrate is right here, and everything that combines with nitrate is soluble. If it's soluble, then we give it the state aqueous, or AQ. So we'll write that here, aqueous. Then, since this one's aqueous, we need to check and see if silver chloride is aqueous or solid as well. So it's easiest usually to look for the anion. So let's look here, and we can find chlorine right here. Chlorine says, does a compound also contain, here it is, silver plus? Yes, it does. That makes it insoluble. If it's insoluble, then we give it the state solid. Since we have a solid state, that means a reaction has occurred. This means that a solid precipitate will form out of what just looked like a liquid before. So then we need to go back and balance the equation. On the product side of the equation, we have 2 nitrates. So that means that we need to have 2 on the reactant side, but we only have 1. So we'll put a 2 here. But now we have 2 silvers over here on the reactant side, so we got to put 2 silvers over here. Now we have 2 chlorines, but we also have 2 chlorines over here. Now we have 1 zinc here and 1 zinc here, so that equation is balanced. Here's another example. We'll react strontium sulfide with lithium chloride. So remember, we want to pair the metal from here to the non-metal from the second one. So we're going to pair strontium and chlorine. We'll put these parentheses to remind us to go back. And we will pair the metal from the second one with the non-metal from the first one. So we have lithium and sulfide. Since these are ionic compounds, we need to check their charges to make sure they balance. Strontium is 2 plus and chlorine is 1 minus. So we need 2 chlorines to cancel out that strontium. Lithium is 1 plus, sulfide is 2 minus. So we need 2 lithiums to cancel out that sulfide. Alright, so next step is to see if a reaction occurs by determining if either of these products are in the solid state. So let's start by looking for strontium chloride. If we look here, we have chloride. And chloride, the question underneath says, does the compound also contain silver 1 plus, mercury 2 plus, or lead 2 plus? And the answer is no, which makes it soluble. So we'll put aqueous here. Our next one, lithium sulfide. So we can go about this 2 ways. We can look for sulfide. It says, does the compound also contain lithium? Yes, which makes it soluble. Alternatively, you could have looked for lithium here, which is always soluble. If it's soluble, that means it's also aqueous. Since neither of these products that are possible are a solid, that means that, in fact, this reaction does not happen. There is no reaction. Let's look at one last example. We have sodium carbonate and cobalt 2 chloride. So, just like in the last examples, we'll pair the metal from the first one with the non-metal from the second one. So we'll put sodium together with chloride. And then we'll put the metal from the second one with the non-metal, or the anion, from the first one to give us cobalt something carbonate. We want to make sure these charges cancel. So sodium is +1, chloride is -1. That one happens to cancel already. On this side, carbonate is 2-. Cobalt is a transition metal, so we have to go back to the reaction side of the equation to determine the charge on cobalt. This chlorine has a -1, giving this total compound -2 charge since there's 2 chlorines, which means this has to have a 2+ charge to cancel that out. Since there's only 1 cobalt, that means that each cobalt has a 2+ charge. 2+ and 2- cancel each other out nicely, and so these are our possible products. Now we need to go look at the solubility chart to see if either one of these is insoluble. If we're looking for sodium chloride, sodium right here is always soluble, or chlorine is right here. It doesn't contain silver, mercury, or lead 2, which makes it soluble. So we'll put, since it's soluble, we put aqueous as its state, and let's look at cobalt carbonate. Cobalt carbonate is best found here under carbonate. It asks if it also contains sodium, lithium, potassium, or ammonium, and the answer is no, because it contains cobalt, which makes it insoluble. Since it's insoluble, its state is a solid, and that means that a reaction does occur. So we can go back and balance this equation. If we look here, we have 2 chlorines, but we only have 1 chlorine here, so we have to add a 2. Now we have 2 sodium, but we also have 2 sodium up here, so that's okay. And we have 1 carbonate here, 1 carbonate here, 1 cobalt, 1 cobalt. So this equation is balanced.